you can determine your S, because the gamma here and the phi here. But it's a pity that you have a phi prime here and you have the gamma prime here. So actually the gamma prime and the phi prime you can obtain from these two results. But you have only 2 days left. So and also you need, even though you can solve the phi prime and the gamma prime, you still need to plot the graph. So 2 days, what to do? So I think maybe you're just up to the derivation, and let's say if you don't have the graph, then should be okay lah. You get what I mean or not?
No, doctor. So doctor is suggesting that we complete the part until the derivation, but how about the results then?
What is it?
How about the results then? I mean, how about the graph?
The results you have only up to the derivation until this part lah. But if you can plot the graph, actually from because last time I do correct the results in the derivation. I think you all have my derivation. From the results. From the results. From okay, this I put in the box. From these two results, you can get the gamma prime. You derive, you differentiate every term respect to z directly. You can get the gamma prime, gamma prime z. The derivative. But of course, there are gamma prime z from here. There are gamma prime z from here. So after you derive, you need to you need to rearrange, right? You can get the d phi over dz. Okay, I don't want to say gamma prime. You can get the gamma over the lambda, not gamma, the lambda over dz here. You can get the d phi over dz here, because this s, this okay, this gamma prime actually is d lambda over dz, right? And then this is d phi over dz, right?
Yes, doctor.
Okay. And then if you don't want to, if you cannot get the lambda over dz here, you can go back to your calculation. Okay. Here you already have the, okay, you know that from the derivation you already have the d phi over dz and the lambda over dz, right?
Yes, doctor.
Okay, you can somewhere you can manipulate from here. So you can say, okay, but of course you have to replace first. You have to replace first and before the integration. Okay, integrate, you have the results. Okay, this is the simplification. This one, you integrate, you get the results. You integrate and rearrange, then you get these results. But before the integration, okay, this is you simplify by divide by this. And before you integrate, as I said, you integrate, you get the result. But you don't want to integrate them, because if you do not integrate, then you already have your the lambda over dz, right? Am I right?
Yes, doctor.
You just you have this, and then you have this. You just collect it, factorize, and you can have the factor, and then you can substitute into your this actually is the lambda over dz, right?
Yes, doctor.
And then it's the same as phi. Okay, where is the phi? There is another one for phi. Okay, for the imaginary part, you have the equation for phi, right? Just now you already solved your d lambda over z, right? You can replace here. But of course, before you replace, you factor, because there are two terms here, and then you factor it, and then you can substitute the d lambda over dz here, and then you get your d phi over dz.
Okay, doctor. Understand.
So after you obtain it, and then you substitute into this, then you get your S already. Okay, so that's why I don't know whether 2 days is enough for you to reproduce a graph or not. Because when you need to reproduce a graph, you have to define your P from the phi and the lambda. And then this is nonlinear. And you need to use a programming to solve the nonlinear to find the multiple roots.
Okay, doctor.
But try your best.
Okay, okay. I'll try my best.
You get the ideas?
Yeah, yes, doctor.
And you know when you want to plot the graph, you need to put all these values. But of course, all these little gamma here, the frequency here, the alpha here, you just put a value. And beta, you just put a value. For example, 0.01 or 0.1. 0.01 is a small damping. I mean small nonlinearity, because beta will determine the nonlinearity, right? If
Yes.
0.1, that is a large nonlinearity, and then this damping, if you put 0.01 is a small damping but still there, and large damping is 0.1, something like that, right?
Yes, doctor.
And then this is a constant, then you just put a value, or you can you cannot assume 0 because there is a direction here. And if you want to get the gamma z from here, because you need the gamma z in order to put into your P, you see the ln here, you need to take all this part to the other side, to the other side of equation. You leave the ln alone, and then you take exponent, right?
Okay, doctor, noted.
Then you can keep the ln. And then here you have the exponent lambda squared, exponent something. So that's why it's difficult. You need to get the root. So let's say if because last time I can see that you can find the root by using Python.
Yes,
So
doctor.
so if this happens, if you want to plot the graph, then you can just provided you can make it run. You can make it run or whatever, but the thing is, if you want to find the root, then after you take the exponent, you have the lambda z equals to exponent blah blah blah, these things, and then remember your quadratic equation. Your quadratic equation is ax squared plus bx plus c equals to 0, right? And
Yes,
then
doctor.
your ABC is a constant, and your AB and you can look at all these equations. You have all these are constant. Frequency also constant. Everything is constant. Everything constant except your it is not quadratic, but you have the lambda square, you have the lambda form, but the idea is the same. The idea is the same. And if you want to solve the, for example, if you go back to your ax squared plus bx plus c equals to 0, and of course you can use the formula. You have the x equals to plus minus b and square root and so on. But this is complicated. So you can put when you want to solve the root for the lambda set, you put it into the programming of the Python to find the root. Then you can vary the lambda set